La 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 la. So I hope you guys saw in the last video the bottom of the screen. It seems like I was cut off when I watched it on YouTube. But then I did a private room video saying, "Look at this, guys! They're beating me up. They've cut off the bottom." And in that video I did for the private room, I can clearly see it wasn't cut off. So it's weird my format that I watched it on. Okay, that's a gray cat playing with something. So she's an old cat, but she's got some play in her. Something that is in a box, so she decides it's got to be flipped. All right, so I've talked to you about offset columns and steel, and what's this been? A couple of years now, 3 years. I mentioned, hey girl, can you take that somewhere else? I talked to you about how do they do this? How do they do 16 number 4s here? Yeah, I'm going to see if I can get rid of her for a second. I don't want to really discourage her from playing, but I just want to show her. Here, come here, girl. Here you go, it's yours. All right, I just took it out of the box where the echo would stop. But she might have liked it in the box. Nope, she's playing with it outside. Where I said, you know, we talk about lapping length and rebar, and one of the trolls I like to do with lapping length is that, hey, if lapping length worked, then it wouldn't matter where we put the laps. So it wouldn't matter if you put it in the negative part or the positive part of a slab or beam. That lapping length, if it worked, it wouldn't matter. Wherever you put it, doesn't matter. The lapping length works. But obviously through extrapolation, ACI is stating that lapping length does not work. It does not work. It's a myth that lapping length works. So you can lapping length your 30x, your 40x. You can go, and some people hate that because they're like, no, architects, a couple architects told me, no, you got to use a new formula now for that. You can't say 30x and 40x. This plan uses x, all right, so many times greater than the diameter. But it's only when. I say when because this is the original plan, 11 foot 10 and 10 foot 10. I'll step us up and you'll get it, but this is the legwork behind it. So here are 16 number 4s, does it start from the outside of the critical shear zone, or does it start center line or in the face? I'm going to argue the face. You start there. Well, that would be 1, but we know that's not true. They don't have it in the middle, so maybe they started on the face. Or maybe, as I said a few years back, that they measured from here to here, and they divided it by 16. And I said, oh, that's our spacing now. It's, 7.3 inches, whatever it may be. And then same thing over here. They said, space from here to here and divided it up. Oh, and as we get closer, these now get closer. Wait a minute. Closer? This line doesn't look skewed. This one doesn't. Oh, they just dropped it by 2. So in a parking area, you lose 2 pieces of steel over here, from 16 over here where you drive, or where you turn and park, you lose 2 pieces of steel. It becomes 16 4s to 14 4s. But you get a BMA in there to help support some beam action. Let's see if I can get this right. So we fast forward to the updated plans, 11 foot 10 to 11 foot 10. Oh, they did this same thing. They still have 14 4s here. 16 4s and 14 4s. Oh, well, maybe they increased the critical shear zone. Here's 16 5s and 16 5s and 18 5s. So 16 5. So before 16 5, 16 5, 16 5s. Oh, they didn't. Okay, scratching head. Okay, so they didn't increase that. This is my butterfly area. I won't step out of it just yet. We come this direction, and they go from 14 4s. This is 11 foot 10 elevation. It's a step down on 1 foot to 10 foot 10. They go from 14 4s to 21 4s. between the same thing, you know, however they do this division. Remember, this is skewed. This is no longer in the rectangular array. This is out of bounds by many feet. This is out of bounds by many feet. This one. It's in here. As you can see, this is the 11 foot 10, 10 foot 10. There is no, even though this was here, there's a beam here, so they didn't bother with the making a critical shear zone, this critical shear zone steel, because it was steel going up to this 90'd. Yeah, this detail doesn't show. They're down here. Here we go. It was going up to it 90'd and anchored to the bottom of it, making that drop that drop slab detail 1 foot. So basically equivalent to the 11 inches up there by the 1 foot 11 right here, where this is 1 foot 11. It's now been reduced by to 11 inches. So this is if it was in there the. Oh, that's nice. So this is a BMA, and I don't get to call this anything. It's not even labeled. It's 1 foot. Okay, so 1 foot drop. So they go from 14.4 steel to 21 because they're going to do this drop. You're going to 90 it here, as this detail shows here. 5 number 12s are going to be anchored to the face of it here, and on the opposing side, 5 number 5, 12 inches on center. Yeah, I'm sorry for saying 5 number 12s. My brain just was thinking about this. 14 number 4s. This is number 5 at 12 inch on center. This is number 5 at 12 inch on center. Staggered? I don't know. They cross each other. I kind of have a theory about hook steel crossing each other. I kind of like it. Hook steel. I know I called that hook just now, but in my mind, I saw that. But also, I want to talk to you about my hook steel design. Is that you come down and you hook, and then the other steel from the other direction comes down and hooks into it, also giving a greater, cancel, giving a greater hook. Let me see if I do this right. So it would be this way. Here's the thing, the stress from each side, though, as you can imagine, each one trying to pull apart. If they're doubling down, this is leaning that way and this is leaning that way. Your stress, it's doubling in the same section, which is pretty clear. You probably don't want to do that. So you might want to share it a little bit. You know, you get your own little spot and I get my spot, and the next one duplicates over here, and so on. And you duplicate this direction, your hook. And you duplicate your, I'm going to call them cones, pressure cones, the force that's created. And it's only within that about 12 inches of wall. So you get 12 inches to try to resist this. Now that's pulling there. So you want to put some steel this way to stop that cone from blasting out. The forces are upon this rebar, and whether you like it or not, whether it offends you or not. Let me move that over. Think of it like that. Okay. And that goes that direction. And this will be unwound, if you will. If you pull past that position, you're just going to rip this out. How do I know that? We can look at the building wall, and that's that little mini zipper effect happening. But that was with the 90s. So we literally know what happens when you turn 90s in a wall, and if you can make the deck fail. This building has a lot to teach, and I'm not sure if the teachers can teach it, meaning NIST or the other people that attempt to teach this. They're missing the, I'm sorry, this one won't even need it. How it unzipped from the wall. That your anchorage, I'm at the wall now. Pretend like I'm at that wall down here, this wall. The jealous wall, I called it. is that your anchorage is only that 12-inch, whatever's it's inside here, whatever's inside there. And remember, I showed you this thing here. Great. And let me move that away. I'll put it back. So whatever's inside here, oops. The forces are first out here, working their way in. This is a little cone, and this cone rips out. Once it does, this is just left to unzip the rest of that concrete. So here's your, even though this development length and this anchor does help, it increases, it really does. But at time of failure, this is the way it looks like. It just unzips this son of a bitch. It blasts it out. You get that cone effect, and then you see this just unzip the back of it. So all of this comes out in one section, and then your last piece unzips from the back of from the remaining rebar. So you could probably argue that the cone is a little more like that. And then the overlapping one is the same. That's why you get some infill of concrete here. Okay, so let's go with, so let me get out of this one. And let's look back at this offset column deal. And this is where the column is. This is the one with the planter box that acts up, right? So your deflection is this way. Originally, so deflection's down here, what I call the butterfly zone. All right, so because of butterfly wings, again, for people that don't know, a butterfly architectural roof, that roof looks like this. It's built back in the 50s mostly, and the roof comes down this side and this side, and the gutters here. It can't be built everywhere because of snow, but it comes out this way, and your house structure can fit underneath of it. It was a thing. All right, so this is out of the rectangular array. It was out of the rectangular array once they removed the BMA. Initially, this would have been loading over to here, though. This distance here to here with the 5 number 12s. As we see in the new plans, don't save. As we see, let's see, 10 for 10. The old plans has that, and it goes over. As we see in the new plans, the elevation is 11 foot, 1110, 1110. But all they did was get rid of the structural, where are you? Right there. All they did was get rid of the BMA coming across here and the other one coming this way. All they did was remove it. The 14 number 4s stayed. The 21 number 4 stayed. All right, and this is coming out of that wall area over just a certain amount. There's a 5 number 5 at 12 inch on center off that wall, and there's the 8 number 5s. 8 number 5s, 5 inches 12 inch on center. Some are hooked, some are 90s. I didn't make this up. You clearly see they're hooked. But the hooks are interesting. It's outside of the wall system. So some are 90s, and some are, I feel like making a joke now. Some are 90s here. See the 90s? And some are L-shaped, right? 90s. This is that higher elevation. As we go to the new plans, you lose the hook. The hook is no longer present, and they just drop into the 90s right here, 5 number 12s. So we lost the hooks. All right, so we lose the combination of these, the combination of hooks and also 90s, engaging maybe engaging the wall itself. Not just sitting on top. This is the part that engages the wall, but and maybe this was their intent there, but nevertheless, it never came to tuition, did it? Tuition. Get it? Tuition, money. All right. You guys know I like playing with words. 14 fours, 21 fours. Okay, so there's a 21 fours in this zone. All right. So then we go back again to the updated 21 fours. All right. Let's look behind it. 21 fours again and 20 fours. 21 fours and 20 fours. So 21 fours, 21 fours, 24. Shit, nothing's changed besides dropping some structural member. How about 22 fours behind it? And behind it, 22 fours. Okay, so nothing changed there. These columns stayed in the same position as far as I know. Now we come to, this is the O plans. So here's a BMA, beam type A, whatever you want to fight over me with. It has a critical shear zone over it. 16.5, 16.5. Both of them do, no matter what the configuration of this is. It's still 16.5s. The newer 11 foot 10, same thing, 16.5s. Now let's look above it, between the two of them. Let's put it right here, rather, before it. 16.5, 16.5 for clarity. This is 16.5s, 19.5s, 19.5, 16.5s. Okay, so they're the same. They're right behind it. Right there, same. This offset's about 8 inches, I think. I forget whether it's out of bounds or not. This is the 1 foot 11 transition. This would have made a stronger beam action across there, but they reduced it to 11 inches. So they got rid of 1 foot, just extra, and threw it away. All right. As you can see, I'm trying to find it here. Huh. Okay. So I'll come here. So as you can see here, it's 10 fours and 10 fours between here and here. 10 fours and 10 fours. 10 fours. Wait a minute. Okay. So there's your 16 fives and your 19 fives. See it? 16 fives and 19 fives. 10 fours and 10 fours. They got rid of that there. 10 4, 10 4. 10 4, 12 4? 12 4? So 12 for $2. All right, so there's that one for orientation. There's your one column turn the other way. There's the one column turn the other way. So I'm off. So I'm off by, uh-oh, she's looking at something. I'm off by 1. 12 fours, 10 fours. So I went to the right. All right, so I can roll with that because I was going to do it anyway. So so right here, that's what I was trying to show you earlier. That here they, shit. At the end of this 7 foot, they show 10 4, 10 4. That's why I got shifted over again. I did this before and I got shifted over and then I did it again. So at the end, it should be 10 fours here. And then for clarity, it should stay 10 fours here also. And then 12 fours. But here, and the new plans, they just show 10 fours, 10 fours. All right, there's a reason behind it. Here is where they remove the BMA. There's 14 fours here. Remember, this is the as-built, roughly. Here's 14 fours here, and 11 fours here, and 14 fours here. I just try to remember. 14 4, 14 4, 11 4. It goes all the way back to the stairs now. Yeah, I'm starting to remember something else too I want to show you. These go back to the wall. To the wall. And this is the... Right. This goes back to the wall. Number 5 at 12 on center. 5 at 12 on center. There's 11 fours coming through this pathway now. This is the 11 foot 10. Oh, this is without my BMA in it. Yeah, this is the equal one, right? All right. So 11 foot 4 going back to the, sorry for confusing you if I did. So 11 foot 4 going back to the 5 12s. here was the going back to the wall, but you had that shorter span. There was a beam here, and now it's turned 5 on center. Number 5 rebar is 12-inch on center, 1 foot drop. So there was a little section here that was tied in from this wall to this wall. It still went across this area here, across. And that, no, it didn't stop there, but it stops over here. All right, and then a new drawing too. 11, 10, 11, yeah. And then now we also stopped here in the beam, and it was 5. It was the number 5's 12-inch on center. Again, if rebar lapping length is supposed to work, these are weird in that they're saying number 5's at 12-inch on center. Where are they supposed to go? All the way across? And it's number 11, 4 on center. Are they supposed to go all the way across? Well, if that was the case, look at the 16 4s coming this way. They changed to 14 4s. It's impossible to lap them, considering these spacing is equal. Here to here is equal. It's impossible to get a lap dance. It's impossible to get a lap dance out of this because there's 2 of them off. It's just impossible. So how were they? Where was this terminating? These 14 4s. Where were they going to bypass each other? Where were they going to stop? Well, I think they mentioned somewhere the steel is, yeah, right here, 4 at 12-inch and 20 foot long. So apparently there's just 20 foot long steel they're using. Just extrapolation. I don't know that to be true. So 20 foot, it was going to end somewhere there. Maybe it ended right where it broke. No, it went further over. So there was some type of weird lapping going on. What I'm trying to see if in the images, can we see this failure? Do we only see the spacing at whatever the spacing is from here to here? If you divide it up, do we only determine that those are the 16 4s? Or when you divide it up, do you count the steel differently? Do you count the steel here in the ceiling, let's say 16 positions or 14 and one's over here you can't see and one's over here you might not better see? So do you count the other, do you see 14 fractures here from the ceiling view? And from this view, do we see, well, probably confusing, it would be 14 4s. So it sort of give you the same answer. But it shouldn't, though. It should be, you should see 12 if they went from the center line. But they didn't go from the center line. I think they went from the outside. And then he divided it up. I mean, it really caused a problem for me. The steel, this whole thing, this whole lapping length matters. And then he just blows it off because it can't lap. This cannot lap. All right, and there's no skewed steel that tries to pick up the forces. You can do skewed steel. Let's come back to my favorite spot over here again, even though it's down here. I want to come back to dive inside this section here because this is kind of important. On the ground, I showed you in one of the videos, the steel, I said this is the pad, and you see some steel just on the edge here. But when they cleaned it off, it was just this section with some loose steel here. But remember that steel comes across this critical shear zone. It comes across where it says 11 number 4s. The BMA is no longer there. We still have the 11 number 4s, but no. I said no BMA. So for clarity, there is no this continuation here doesn't exist, or the one here, the 1 foot step down. So the steel, you get 8 number 4s coming across. Let's say this BMA here, this here, and this here. Here, it's not identified besides over here where it says 11 number 4s, but the butt part is, does it continue across here? I can't determine that. Because part of that would start when the deck goes down. Remember, we only see a little bit of rebar here. Did they lay it this way? This counts as development length. Part of it would be torquing on the beam. it broke free at one point. You know, these BMAs, beam A, whatever you want to call it, they went down, right? We see that planter box deal, and I believe it's Ring Around the Rosie. Over here, we see it with the this one, with the fire guy that I showed in the video standing on top of it. So it's still proud. And then over here, we see it with the what I call the hair, like a wig on top of it. That's the hair that went the hair. The bush that's still sticking on top of this one, and further down here you see the bush on top of each one, the shrubbery, the bush. Okay, so here your direction here, 10-4, 10-4s, and then it also turns and engages more. The 5 foot at 12 inch on center. This is when it was 1 foot 11 inches. The number 5 rather, 12 inch on center. And over here, this is the equal up. They still do it. They still had that extra rebar coming off of here this way. And they had the other rebar coming off in the other direction, but that is elevated. They're not at the same height. It's interesting the scale they use. This one looks larger than that one. All right, so the top part. Now this is in the deck. So these 90s are in the deck. This is in the deck where they put that little lower planter box. And then this is above. These 5 number 12s are above, including tying in over here. It's only 11 foot long. They could have fabricated this as one piece. That would be very nice. It would also explain why it can go down at 1. You rock this, why it would come down as 1 if this is one piece. They don't show it as one piece. 5 12 inch on centers and 12 inch on centers. So theoretically they come out and they overlap. And then over here, continuing down, this would be 5 on center. Yeah, overlap. I'd argue that they overlapped at the top deck. At the bottom, there's, of course, no overlap. It's at the bottom of that beam. Remember, it's 11-inch step up. So, can I see it over here on this drawing? So here would be the 5 number 12s at the top, where you get that, let's call it 11 inches, varies. 11 inches. And then you step onto that patio into another 7 inches. You step into the product, into the 111 room. This has the 90s here. It shows straight, but those are the 90s, and they're 12 inch on center also. So you can see that you have some load here and here. Now this is a beam. It looks like it's just at the bottom, 2 number 6. All right. So this is that beam here. Here's a beam here where they step up, where you would see that top and bottom thing. Don't get too crazy about this beam. Needs to stay stable. This span is very, very small. Well, not very, very small. It's small, 11 inches. You know, this is smaller, 7 feet. But we get this going down because we see the planter box. This is all destroyed. We can't tell, but besides the video beforehand of the lady filming down here. But over here we see the shrubbery all standing proud, as if it just dropped straight down. So then back here, 10 foot, 10 number 4s. So 11, 10. So it's 10, 10, right. So this is 11 foot 10 height. So there's your 10-4. So your rebar is going across. So I'm guessing that it made it across out to here, and when the deck went down, it had its deviations where it was able to do some ripping down on its own. See, I think this deck went down in 2 sections at least. not just one. And part of it helping it go do that would be the engagement of that length of the rebar and the spacing, which it may, allows for no lapping, even if it did work, even if lapping did work. It doesn't allow for it because they don't line up. Here's 11 number 4s, and this is 8 number 4s. So this is a stronger section. This is the 11 foot 10. Yeah, this is the build, the one is intended to build. So this is a stronger section here in that capacity, but weaker over here because now they switched to 8/4s. But the 8/4s, did they go? Oh, there it is, son of a bitch. There they are. Huh. Right across, 8/4s. Yeah, I don't see it here in the 1 foot 11 step down. I don't see them coming across here. I knew they were there somewhere. I started getting crazy on myself. There they are. So there's a steel going across the 8/4s. So the 8/4s, they stop here, or did they stop right here? The 8/4s division. So you do 8/4s from here over to here. Oh, but wait. This sticks out further. This is 11 foot. That's 7 feet. That's a difference of 6 feet. I know it's not. I'm just having, you do some work. I'm trolling. So they still use 8/4s, but now it's a shorter span. So the spacing again, no overlap. So 8/4s from here to here. It's still saying 8/4s. So it's impossible for the steel to overlap this side to this side using the same amount of steel with these pretty much in line except for this 8-inch offset right here. And this being set back 4 feet. This would be a weaker section because of that steel. Now it still has the 5 number, the 5 number. The number 5 at 12-inch on center. All right, looking at the bottom deck, right, not the top. See the direction of the 90? That tells you it's upper, and this is the lower by default. And then over here, you have the number 5's 12-inch on center. So right across here is all equal with that, with these 90s, all the way across. Okay, fair enough. But remember, this is a composite beam, as I show you in video 2. So this is this lower section front, lower section where the water damage is, stops right there. And it has an 8 number 4s going across. As soon as you go beyond that, there is no steel going across anymore. It's butting up to, and that's the 5 number 12s at the lower section, the deck section, the lower deck section. At the upper deck section, you have the 5 number 12s, 5 number 12. Number 5s at 12-inch on center times 2. Each one's my mistake. It goes over to here where they have what it looks like an elevated, parting beam, if you will, sitting on top of this one. It's elevated up to the top of this. This deck is not a step down. This is equal. But with that said, being equal, they still 90'd it. Look. They still put the 5/12 on center here too, and the same here. Whoa, yeah. What don't you notice? None over here. So they tied it here, but not to this side. Okay. They tied it from here, but not to this side. All right. Over here, you see it tied there, and you see the direction of it. All right, going back that way also. And there and there. Again, the deck out here has the 90s tied into the side of it. Now, did they run these 5 number 12s, as it states here, 12-inch on center, down the entire side of the BMA? Or did they only stop right there? I don't know where they stopped. Did they stop down here? Or did they stop right there within the deck? This one clearly is elevated, so it stops in the deck above. It's the elevated deck, stops in above. But this one's low enough at 12-inch on center to be on one side all the way down, which would have some crazy overlapping because this already says 8 number 4 is, I'm sorry, not this one. This one already states 8 number 4 is coming across. So I would theorize that they stop the 5 number 12s right there. All right, so that beam is kind of cocky right about there, strong out to there. And over here, it's no longer, and it's got a little torque on it if you have deflection here, if you could get it between here and here. It would create a torque action in that beam, which creates some separation. But you also have this 8 number 4 is going across that will not overlap. I'm getting redundant. I'm stopping now. I just want to say that if you look at this, there is no overlap. The steel can't overlap with the numbers they're using. Here's 10 number 4s, 12 number 4s. They start spacing it differently, but there's no detail saying make sure you overlap 21 to 20 number 4s, and this distance is about equal from each other. This is 8. This is 8. This is 8 inches. This is 6. Something like that. They just can't overlap. No matter how I look at it, they don't overlap. So, what does that tell you? That ACI, they were supposed to follow ACI rules, but there is no overlap. And again, current day, I like to tell you that overlapping steel doesn't work. If it worked, it wouldn't matter where you put it. There will be no part about you can't overlap steel in the negative moment here, and we'll just call it the sagging part of the deck, guys. You don't overlap. If you were to do a beam, all right, I'll give you a quick version of what I mean. So if you were to do a beam, and this is the outside of the beam, and then I'll put the steel in. Well, that kind of works for me, actually. And then we put the steel in down the bottom. This is not where you overlap. Okay, not the overlap where the deflection happens. This is because they tell you it's you don't overlap there. And again, if overlapping worked, it wouldn't matter where you put the steel. You could put it anywhere. So I'm telling you, overlapping doesn't work. So if you want to start evaluating your structure, start thinking about the overlap. Where do they put the overlap, and what friggin' good is it? All right, what good is overlapping if it doesn't work? Again, if you overlapped here, it would be wrong. Overlapping in the center. And you would say it would distribute the anchorage, more surface area, etc. It should work there, but now it doesn't work there. So up top here, your overlap, you can put the overlap up there, but down here it will be over here. You could put it near the end of the support, your overlap, but they want to see solid steel in the center. Okay, so again, finalizing, you saw this crap. Overlapping can't happen. They remove BMAs. They have triangle array offset issues. The overlapping steel is just, it just sucks, especially this one. It's the one that was so easy for me to spot because of the rectangle array. I keep calling it triangle array because it's all it makes. This is literally, I mean, it wasn't like the guy was stupid. He literally put the mark there to show how much he's out of bounds. He literally intersected where it's supposed to be. He does it each time. He literally intersects and shows where it should be and how much it's offset by that. So this is craziness. This angle, if you take it from here, it's like 54 degrees. If you take it from here, it's like, I forget, 17 degrees or something. Just that section alone makes it out of bounds. He had to add more columns. He had to move it. There is no, or skewed steel. You could do the skewed steel thing, but that's going to get complicated. You're making a beam basically going across, and you're trying to transfer these to that beam that would then transfer to that column. It would get pretty nasty, complicated. All right, you closer to steel, get your steel closer too. Remember, this is some huge ass distances, and at least here he spec 12 inch on center. Here he's like, I don't give a shit about the distance. Just 20 of them. Number 4. Divided up. Here. Over here. 22. All right. So, and I ask you just for the sport of it, what's the difference between this distance and this distance? They're the same. This one here to here and here to here, and yet there's 2 extra pieces of steel. I'm tired. Enjoy. Remember, this is what I want you to see. The 8 number 4s, they don't overlap. They go across here, and when the deck goes down, we see part of that when the guy's scraping and cleaning. You see that little bit of rebar sticking out. I believe it's the 8 number 4s. Could be the 8 number 4s. And that's the other deck that just tore apart. So somewhere about here is the overlapping steel from this 11 4s coming this direction. And I should say bypassing steel, not overlapping. All right, I'm done. I am done.